Hello and welcome to another episode of the CG Garage. This is episode number 468, featuring Alex, Yolov, and Gosho Genchev, who are the product managers for V-Ray for Maya and V-Ray for Houdini, respectively. They're awesome guys. I love working with them. And it was really great to bring them on because I needed to get their input on some new stuff that's happening, specifically V-Ray 6 Update 2. There's a lot of new features involved, and we talk about those features. But the big one that we needed to discuss was MaterialX. As you guys know, a lot of people know what MaterialX is. Some people may not know what MaterialX is. Some people want to know how we use MaterialX or what we're doing with it. So lots of new stuff happening in that area, and then really want to dive deep into it, and we definitely do on this podcast. So if you guys are interested in that, this is the episode you are definitely going to want to check out. Okay. I also want to let you guys know about something else. I am currently working on a very, very big project, and it's keeping a lot of my time. And if you guys want to know what that project is, can't really tell you, but there is going to be an announcement probably sometime this week. I will say that it involves Vantage. And so you probably will be able to figure it out once you hear the announcement this week. So keep an eye out on that and let you know. It's a very exciting thing. Something I've been working on. I could actually say probably working on it for about 10 years. But the last year has been this new project, and it's been very, very exciting. And I'm very excited to be able to talk about it. But it does imply something that I think you guys should know. Because I'm sort of in the thick of it right now, it is going to make it more challenging for me to put out podcast episodes in the next several weeks. So there might be a couple of week gap where I'm not going to be able to put out a podcast, and I want to apologize for that. But we will definitely be bringing them back up, especially when I start talking about this project. There's going to be a lot of podcasts about it, and I'm very, very excited. So keep an eye out on that, and just go to chaos.com to follow all the news, and I'm sure you'll find out more about this project this week. Okay. Do want to mention a couple of other product announcements. I did mention V-Ray 6 Update 2. Obviously, this is what this entire episode is about. But there's also Vantage 2 Update 3. And that's really cool too. As you guys know, I just mentioned I'm very involved with Vantage. There is a lot of great updates, including the big one is layered materials. Yes, layered materials are finally supported inside of Vantage. And it's a really big update and really cool because that opens up the door to a lot of new features and new possibilities. And we also included some new multi-mats specifically as render elements, which is cool. And several UX changes that I think are really, really useful and great for our users. So very excited about that. Again, just go to chaos.com for all of our product updates. Okay, we have a couple of events that are coming up this week. In fact, probably tomorrow, there's going to be the Creative Lighting Workshop with Nikos that's happening in Toronto. That's April 3rd. And there's also going to be one in New York, April 17th. I do also want to let you guys know that we will be at FMX on April 22nd through the 25th. And that, of course, is going to be in Stuttgart, Germany. So again, just to go to chaos.com/events for all of our product announcements. Now, if you guys want to know more about the podcast, you can just go to chaos.com/CG Garage. If you guys will follow us on Facebook, just go to facebook.com/CG Garage Podcast. And if you'd like to watch any of these podcasts, just go to youtube.com/Chaos Group TV, where we post all our videos, including the podcast. And if you guys have ideas or suggestions of podcasts, I'm still going to respond to those. Just go email us, labs@chaos.com. Again, that is labs@chaos.com. But for now, please enjoy episode number 468 with Alex and Gosho.
Welcome to another CG Garage, where the Chaos Group talks. You'll know it's over when the last bucket drops. We're gonna fire off rays in high dynamic range. We know that ambient occlusion is passe. Global illumination won't lead you astray. And while image-based lighting is really swell, you need to make sure everything has Fresnel.
All right, I do want to talk to you guys a lot about some of the cool stuff that's going on. Obviously, we have been doing a lot of work in V-Ray 6 Update 2, and I want to go through like one by one with you guys and talk about all the features besides MaterialX that we've got in these things and sort of give us a little bit of a breakdown on each one of those. And then I want to go into a bit of a deeper dive into MaterialX itself. So, Alex, maybe we'll start with you. Tell us a little bit about what's going on specifically with V-Ray 6 Update 2 in Maya. What are some of the big feature updates that happened in there?
So we focus so much on MaterialX that I forget what else got in the actual release. But on one hand, there's a lot of things that we added to Chaos Scatter. So for example, you're now able to instance lights with Chaos Scatter, which wasn't there before. There's some pretty cool example imagery that we uploaded. You can check some examples on the website, on the docs portal. There's some pretty cool stuff you can make, like fireflies in your scene for free in terms of memory. There's also include-exclude options that basically allow you to like pick a curve in your scene that's an area that you want to exclude scattered instances around it, so you can it makes it easier for you to make like a sidewalk or a path where you don't want grass to be scattered upon, or you want grass to be scattered upon, stuff like that. There's a lot of improvements there. We also got the edge trimming thing added in 6.2. It was highly desired. It was already available in some of the other integrations, but wasn't there for Maya.
What do you mean by edge trimming, so people get a better
understanding? Edge trimming. Yeah. Good point. So edge trimming is where you're doing a lawn.
A lawn, yeah.
Yeah, and you want. It's like you got your gardener to trim the edges of the of where the lawn cuts with the pavement, for example, or something like that. It's a pretty neat option if you're doing exteriors, for example. It's pretty useful. Let's see what else. One thing that's really interesting is that we got something called shadow selects. It's not uncommon in ray tracing. Other products have it. It's nothing new, but we added it in V-Ray. It was requested by some VFX customers. It's basically something that allows you to output for compositing additional passes where you can break down the shadows casts from specific lights.
Okay. So it's like light selects, but it's shadows instead of lights.
Light selects, but for shadows, yes. And there's some improvements there that will be added a bit further down the road. For example, they're only available as a setup similar to the regular light selects. You create a light select, it acts as a set in Maya, you add lights to that set, and that's how you are able to isolate shadows based on specific lights. But you're not able to use them with light path expressions for the moment. And the ability to use them with light path expressions is coming. It's something that we're currently working on.
Okay. Yeah, I was going to ask about light path expressions because that's the natural next question. Oh, can I do it in light path expressions? Yeah.
Okay. You will be able to do it really soon.
Here with a tiny little thing.
What was that, Gosho? Sorry.
Is it okay if I interject here with a tiny little thing?
Yes, of course. This is a conversation.
Right. Yeah, it's one of those Houdini VFX studios that asked for those, and Alex is probably not in the loop on that particular thing. The developers also managed to get light path expressions working with the shadow selects, but only on GPU at the moment. So we're trying to get that working for V-Ray CPU as well, so you could do those really huge scenes and render them as well. But if it was something minor, if it was a product visualization, for example, that already works with V-Ray GPU. And the really cool thing is the ability to get those shadow selects working with matte surfaces. So if you had a backplate and you wanted to isolate the shadows on top of the backplate, before that functionality, we would you wouldn't be able to do that with V-Ray. I mean, it's or any other render engine for that matter. But now it would be possible, so it's really cool.
Awesome. Okay. Well, that's pretty intricate and very specific feature, right?
Yeah.
Which is pretty awesome in a lot of ways. Okay. And the other thing you mentioned scatter of lights and instances, and that means that we can put in thousands and thousands of instance lights that are scattered across multiple things, right, Alex?
Yeah. You couldn't instance lights with Chaos Scatter before. Right. Now you can pick them as something you can scatter just as any other object. So you can make pretty much anything, stars in the sky or fireflies in your scene flying around, anything.
Right. That's pretty awesome. Or a bunch of building lights and all this other stuff, right?
Exactly. Yeah. You were able to instance lights as regular instances, just not scattered instances with a procedural scatter like Chaos Scatter.
Okay.
So that's there, hoping it's useful.
Yeah. And any other features before we move on to Gosho and what's going on in Houdini that you can think? If you think of something, you can always interject, of course.
Yeah, I'll just jump in whenever I think of something interesting to share.
Well, Gosho, what about you? What are some of the other features that are in Houdini that have been added? Houdini and Solaris. I guess we can almost think of those things as two different packages in some ways.
Yeah, on the development end, definitely. For the artists, probably not so much. I mean, well, probably for them as well. It's a completely different workflow. Yeah. We got V-Ray in Solaris for more than a year now, but it was a bit of a struggle to get everything working across all the different V-Ray integrations. So the ability to get those USD files and then move them to another DCC and render them there and get the same result. And a lot of effort on our end went into getting that Hydra delegate working across other products as well. And as a matter of fact, there are now people asking about standalone USD builds, and we have those as well. I mean, that's a thing as well. You don't even need
standalone USD build of V-Ray.
Yeah, that's a thing as well. So you could get the Hydra delegate as its own standalone thing and use it to render a USD file, the same way that you would use V-Ray standalone to render a VRC file, which is the equivalent.
Okay. That's pretty cool.
Maybe a bit of a background how people use it and why it's important, Gosho.
Yeah. Well, the Hydra delegate, Hydra delegate is a framework to do a virtual viewport. Is that correct? Is that the right way to think about it?
Yep, you can think of it that way, but you can also think of it as a bridge between the textual description of your scene or binary, which is the USD file, and the render engine. So it's sort of a translation layer, and either you translate it yourself somehow or you use Hydra, the Hydra framework, and you plug your render engine into it.
Right.
And the cool thing about doing it through Hydra is that you could then, if you develop your render engine to use Hydra, you could then plug it technically anywhere that also supports Hydra. And nowadays, the reason people are asking for those standalone USD builds is because they're trying to play around with Omniverse and with Nuke. Apparently, Nuke also has USD support as of recently.
That's what I was going to get at. So, like, besides Solaris, what else uses a Hydra delegate? So, Nuke and what was the other one you said? Omniverse.
That's that's from NVIDIA. Maya also has, as of recently, Hydra support, and In general, it was the main thing that happened between update 1 and update 2 is us trying to get that Hydra delegate portable and accessible anywhere. And then it's up to the different integrations and the people that are working with those to decide if they need USD and Hydra or the vendors that make those DCCs as well.
Okay, let me ask you something, because I remember the first promise of the Hydra delegate, and the reason it's called Hydra is the multi-headed monster, right?
Yep.
And so is it true that if you can use multiple different rendering solutions under a single Hydra delegate and actually render some things in one render and other things in another render, and then have them composited in Hydra?
Oh, that's a very good question. You could, in theory, render the same scene with different render engines and get a very similar result. But what what you're suggesting is quite different. Honestly, I can't answer that question. I, hmm, I'm not aware of such workflows at the moment. But
It'd be
sounds-
interesting. I'm just curious because I was like, why would you do that? And then I was thinking, it's like, be interesting. Like, first of all, the people ask for crazy things all the time. Like, I want to change this specific shadow and not that shadow, which is shadow selects. So I get it. So, but it's interesting just to think about that. But it's cool. So now we have a lot of work that we've done on our Hydra delegate that sort of not only helped this, but helped all Hydra integrations that we could think of in some ways, right?
yeah, that's the goal. Future proofing ourselves, and making sure that if someone needs V-Ray somewhere, it should be possible to get it there. So,
Right. Awesome. Awesome.
Yeah. Besides that, there were some other improvements. I mean, a lot of things went into this update, but the other major thing that I would highlight is what Alex already spoke about, the shadow selects. And I'm really happy that we're gaining traction there. I think that those will be incredibly useful to people, especially with the support for matte geometry and any sort of backplate workflow that relies on real life footage as the background. Yeah.
Yeah. I mean, just for compositing, you could composite it so you can get each shadow to exactly compositing it correctly. So each shadow matches exactly to real shadows. And so you know that the shadows are in the correct space that way.
Yeah. And if you need to edit something, it would be much simpler than, you move the light, suddenly the shadow changes. What do you do? Do you re-render the whole thing?
Right.
Yeah.
Yeah, but also really, it's really common. We understood that it's really common to get asked to tint the shadows or make them darker,
slightly blue, slightly red. Yeah, slightly darker.
Yeah.
Yep. For sure. That makes a lot of sense, guys. That makes a lot of sense. Well, that's pretty amazing. And very exciting. Now, Gosho, is there anything else that you remember that you did also on the Houdini side?
Oh, I have my list here.
Okay, go ahead. Coke through it.
Something really cool. I hope for the people that are using the old sort of, we call it vanilla Houdini nowadays, at least internally. But there are plenty of people that are still using it. I mean, USD is,
of course.
USD is awesome. But it's kind of suited more towards mid-sized or really large pipelines. If you're an individual artist, old Houdini is great. I mean, why not use it? Why complicate things? And we tried to get things better there as well. Essentially, some of the improvements that we did for Solaris and Hydra, we managed to backport into vanilla Houdini, and those are related to the way we treat geometry and how we collect the scene data and how IPR starts. So really, it was mostly improvements and pretty major improvements, if I should say, to time to first pixel and how we essentially parse the entire scene and collect the data that's needed for rendering. So I don't want to dish out numbers out there, but in some cases it was multiples. So it was a multiple times lower time to first
and
pixel.
This is mainly on the time to first pixel situation. Yeah.
Okay. It's also related to, I mean, that goes also into the size of the scenes that we generate. So because of the way Houdini works, people would usually generate a VR scene and then send that for rendering on the farm. That way you don't have to, I don't know if I should discuss that, but you don't have to pay for licenses for, Houdini engine. So you only have to have a V-Ray license, right? If you're using VR things. And that's what people usually do. And one option, I mean, in the past, it was the case that you'd have very big VR scenes, hundreds of megabytes, maybe even gigabytes. Nowadays, it's much smaller. So that was also a side effect of the changes that we did.
Yeah. Interesting. I just give you guys a little idea, and this is how much it dates me. But when I was working a long time ago, I was at a big company, and we were using Maya, and this was RenderMan before there was literally the first thing it would do is they would get a bunch of computers to convert your scene to a rib file first.
Yeah.
Because it minimized the amount of time you were in Maya.
Yeah.
And then after that, it would use the standalone of RenderMan to do it, because it's like the Maya license, they didn't want to have it too long on the farm taking up a license. So it was this whole process of converting and doing all this stuff. Yeah. Okay, interesting. All right. Okay, what else have you got there, Gosho? You got more stuff.
Well, some improvements on V-Refer. Again, that's for the vanilla Houdini. Basically, we made it possible to apply V-Refer on deforming geometry or geometry with displacement on top of it. That's coming from Alembic files. So 99.9% of pipelines that rely on Houdini, they would cache everything to disk, and then they would bring it back in Alembics or VDB files. Obviously, support for Alembic files for the V-Refer is something that people needed to actually utilize V-Refer. Otherwise, you can't just get a deforming character that's hundreds of millions of individual points and cache it every single time for the VRSync file. So it's not a massive new feature or anything like that, but V-Refer is really easy to use. It looks good, so why not give people the option?
I thought it was interesting because you would think, like Houdini people will actually try to, use their own hair system, which is fine and complicated. But sometimes it was like a little too, they just wanted a quick way to just do a little bit of fur, a little something. And V-Ray fur is just the simplest way to do it. And they just needed it to work with the cache geometry. So we added that feature for it. So it's not always going to be used in Houdini, but it's something very useful for I just want some peach fuzz or something quick to make fur work. And that works great. Yeah. Yeah.
Well, I hope it will come to be useful for people. Yeah.
Yeah, that's pretty cool. I mean, I think it's really interesting that development on the Houdini side has been growing quite a bit in a lot of ways, and I think that in general, when you think about all the features that you and Alex and both of you guys are talking about, it's so funny because all of these requests all of these features feel like some TD, some request is like, what I need? I need fur that works in this. Or it's like, can I change this color of just this shadow? Or can is it, and then, I like that scatter thing, but I try to scatter lights and it causes a problem. Like all of these just feel like these very specific requests, which are needed in pipelines that, it's great that we're doing these things, right?
Yeah. In the end of the day, it's, we are here to try to make software that they can use to do what they want to do. And, if someone comes with a suggestion or a request, I'm really sorry about that.
Yeah.
If someone comes with a suggestion or a request, if we can somehow generalize it and make it available to other people, then that's awesome. And
yeah. How has it been with you, Alex, in terms of interfacing with people? You've been doing this for a long time. I've known you for how long? You've been at Chaos? I remember you for many years.
I think it comes up to 12 years.
Right.
Next month.
Yeah.
So yeah, quite a while. Well, it keeps surprising me connecting with customers in terms of like, for example, I was really surprised back when we first did Chaos Scatter for Maya. I think it was the previous release 6.1, because at that point we were rather thinking of not doing it because Maya already comes with some built-in tools for scattering, and we preferred focusing on other areas where we can improve Yuri, add something more useful. But we got literally overwhelmed with requests to integrate it in Maya. It's already there for a number of other products. It's really useful. People love it, and they wanted to see it in Maya. So we spent a lot of time actually change priorities on the spot. Really revisited our roadmap. Actually got it there, got it working. And then we got feedback from customers who actually used it in production on actual shows, and that it was quite useful and then saved a few projects. So it was really surprising. I did not expect that, honestly. Especially given that, for example, large shops would have their own custom tools built for that specific reason, so that they don't rely on anything that comes, out of the box. So it was really surprising that some of the requests are really surprising, and it turns out that people always have a good reason for requesting what they request.
They do, and it's. I think that's the nice thing about interfacing with certain customers is that you never really know. Like, it's not always obvious, right? Right, like adding fur to Houdini is like, why would you do it? They have really great hair systems in Houdini. Why would they need fur? And not to say that our fur system is bad. It's just it's quick and it's easy, and if you just need something, it's just there. Right?
That's the thing with it. It's made to be quick. You just do a couple of clicks and you get fur. It's not meant to be a full-blown grooming system or anything like that.
Right.
But it has
great for carpets.
Works great for carpets, peach fuzz.
Yeah.
I've seen some really crazy stuff done with it. But again, I would assume that people would just use something like Ornatrix, Yeti, Houdini.
Right. Sometimes, as my friend used to say, like back in the day, we had these SGI machines in my school. That's how old I am. Long time ago, and people would get onto the SGI machine and check their email, and we used to joke about it as like, getting onto a space shuttle to go to 7-Eleven and buy a Coke. So sometimes like, oh yeah, I'm gonna do this. Like, yeah, no, I just need to get something done quickly. It's not always. You don't necessarily need the huge thing just to do something very simple. Okay, I do think it'd be a good time to start talking about MaterialX a little bit. Obviously, we've talked about USD in the past, and USD and MaterialX seem to be the two major things that people have been discussing. When we talked about USD, I remember, the early days of USD, everyone kept asking us, "Are you going to do USD?" And people say, "How are you going to use?" We would ask how they're going to use it. No one had an answer because they hadn't used it yet. But it seems now that USD is very well established. Obviously, people are using it in production. They know how they're going to use it. They know what it's going to be. But we've always had that same question a little bit about MaterialX, right? And MaterialX is also a similar thing. It's a material definition in some ways. But we have supported material definitions in the past, many kinds of definitions or many things, right? MDL or whatever they are out there. We've done a lot of them. And I'm wondering, who can tell me a little bit of the best sort of concise way, what is MaterialX as a material definition? What makes it different, and how does it sort of work as a product? Not before we get into how we did it, just MaterialX. Like, who wants to go for it?
I'm not sure I want to open that can of worms.
I've had Zap on, and so that's a different situation. But go ahead and tell us, Alex. You give us your best shot.
Okay, if you look at it from one angle, it's not dissimilar to USD. There's been the list of formats that wanted to standardize how you describe and transfer geometry. Just if we just speak about geometry, is quite a long one. But the thing about USD is that if we forget for a moment that it's not just geometry, it does a whole bunch of other things, is that everybody agreed on adopting it. And that's something that really drives usability. If everybody agrees that they're going to use it and adopt it as a standard, then it becomes something that people can use. And it's same for MaterialX. There's been a number of other attempts to standardize material descriptions, but the moment everybody agree to a good extent that they're going to adopt it and support it, it suddenly becomes a good option for you. Maybe that's something that is different this time. Maybe there's other things. I don't know. Can't think of a better explanation right now. But what is it?
What is it?
What is it? What is it? So it's a way for you to describe entire shading networks, not just a reflective plastic-looking material. It allows you to describe entire shading networks in a standardized way. And to do this, it includes a list of standardized nodes that build up those shading networks. So it includes everything you would ever need. Like it includes an Uber shader, it includes a checker texture, a file loading texture, a color correcting texture, and so on. UV generators and everything else you might need. And if you're planning on building it in one place and using it in another, if both of those places support it at the same level, that suddenly means that you can build something in one application like Maya and move it to Houdini and be able to examine the entire shading graph, not just a black box file that you open and assign, but examine it, look at every single node in the network, visually being able to identify what goes on in this setup. Like there's a color correction there, I can spot it immediately by looking at it. I'm not the same artist who originally created it, but I'm able to examine it and spot what goes on in this setup. I'm able to modify it freely, not just modify something that got converted afterwards or during the transfer. It looks exactly the same.
Down.
No, it's not collapsed down. It's not converted. It's not migrated. It looks exactly the same. It's as if, think of it as different DCCs and different renderers agreeing on looking at shading network descriptions in exactly the same way. Not in terms of producing the same result, but in looking at the building blocks in the same way. Sure. Which I'm sure suddenly opens up a whole new world of possibilities.
Yes, but doesn't it also open up a whole new world of political problems?
It does.
The way that I say this should work or the way that you say this should work is different.
Just like any other standard. Look, it goes down to what we use to build those tools. Right. In all honesty, let's not talk about programming languages, but it goes there as well. Right. It also opens you up to being limited in some ways. For example, if it turns out that this DCC or this renderer doesn't get you a good result with this particular texture or procedural texture that you're using from the standard library, you'll suddenly stop using it. Or the renderer needs to support it better. Or for some reason, if the result is not to your liking or doesn't meet specific requirements, you'll be limited to using what's good for using.
Okay. What about the other situations where, like, for example, you've developed a shader that is not necessarily a standard shader, let's say for creating really good skin, right? And you've got a specific way that it's done. And that method is optimized for your render because of how it works, and it's very fast. And in order to replicate that in a standard system, you have to create it in a different way, and it may not necessarily be defined correctly and optimized for your render. How do you deal with that?
Well, I actually don't recall if the MaterialX library comes with a hair shader. Gosho can jump here and
they have.
And fill in the blanks for me.
Sure that there's a dedicated BRTF or anything like that. Maybe there is. Then we focused on the standard surface material at the moment. So
yeah,
even if there is, I haven't really focused on that.
But even in this case, for example, we are able to represent our own shaders as MaterialX shaders. It's possible in Maya. I don't know if it's possible in Houdini, probably is, but it's the same for other renderers as well. Other renderers are able to give the users access to their proprietary specialty shaders as MaterialX shaders. But that on the other hand limits you to using the same renderer when you transfer that shading network between different applications.
Right.
Because that's the other thing with MaterialX. Another possibility that I'm sure it's a lot of people welcome, because it was probably a requirement when coming up with the whole thing, is that you want to build a network that you don't have to sit down and write a script that converts it for another renderer or manually convert it to another renderer. You want to have one department build an asset with all the shaders, pass it to any other department, any other studio for that matter, that uses any other renderer that supports MaterialX, and you just get a decent result. You don't have to convert it. You just look at the same shading network, you throw it at any renderer, you press render, and there's a result. It might not be exactly the same result. It will likely be a different result, but you don't go through any conversions, any manual work. It's the same thing.
Right.
The other renderer understands it. It knows what it is. But if you're throwing in any specialty shaders, like for example, if you're using the hair shader and you're using MaterialX in Maya, where you can have access to the V-Ray hair shader as a MaterialX shader, you're free to do so. But then other limitations apply. You're tied to that renderer when you move the data across to another application. So there's that.
Yeah, it's interesting. I'm just thinking, you mentioned hair shader. I remember all the work we've done with hair shaders where we integrated different ways of doing melanin and their highlight shifts and all these different things. And I mean, these are all features that were added on a very specific BRDF level that may not necessarily be available as a MaterialX definition for that. I don't know. So it'd be interesting to think about it. Nonetheless, I think MaterialX is an important process that we all need to consider. We need to think about something that we're not just all sort of operating in our own bubble, right?
Yeah, to be fair here, Chris, it's there's also the possibility of using the MaterialX standard and then adding a little bit on top of it. So in your example,
Sure.
with let's say the melanin, let's say that there's the BRDF that's responsible for that, but we have additional controls in V-Ray that we want people to have. It's easy enough to just add those controls on top, meaning that, yes, ultimately the MaterialX file that you're sending will look different with V-Ray compared to another render engine. But at least now there's a baseline of supported functionality that will hopefully be the same between different renderers. And
Right.
over time, we are part of those committees that decide what goes into USD, what goes into MaterialX. And I believe our voice will also be heard over time, and I believe other software vendors also have the same issues that we do. So maybe we will eventually converge into something that's usable for everyone, I guess.
Yeah, I
Uber
think it's
renderer.
good. I mean, honestly, I think it's an important part of what we do, right? Like we've actually been very much a company that has tried to not shy away from open standards, but really embrace them. As long as we don't have, I think Vlado's thing is like, I'm all for open standards as long as people actually use them and are not developing this for nothing. Because we've developed for open standards, many of them that have gone by the wayside, and that's a lot of development cycles that have gone to waste. And so I think he's always hesitated with any kind of standards. I've got a standard, you've got a standard, we've all got different standards. That's not something he wants. He wants to be something that embraces. And it definitely sounds like MaterialX is something that has come up a lot, and it's good that we're embracing it. I'm just sort of trying to manage people's expectations as to how it's going to work. But technically speaking, you render something in V-Ray or you render something in Arnold, and they both use MaterialX. That translation process is not just a translation. It's literally just, it should work, and you can it's still editable, as Alex said, right?
Yeah, and it's maturing. Like for example, when USD when side effects were the first one to really embrace USD with Solaris, and it's they've taken it a long way, but it's also maturing in Maya as well. You're able to do more and more with every release, so things are getting better. There's a process of maturing. And by the way, I just thought of some cool examples. While we mentioned the specialty shaders that other renderers will not be able to understand, and those examples go to USD as well. You are able even now to mix and match between USD data and MaterialX data, like with USD data and native Maya data, and MaterialX shading data and native Maya shading data. If you bring in a USD file that may or may not, let's say for the sake of the example that it contains an asset shaded with MaterialX shaders over to Maya, and you render it with V-Ray, you are able to throw in like a ground plane that is native Maya geometry that has its own native Maya shader, and you just press render, and V-Ray interprets the combination of all these data, which means that you can throw in an asset that has hair without the hair shader applied, and you can shade that hair with either the native Maya representation of the V-Ray hair shader or the MaterialX representation of the hair shader on top of what you get as MaterialX shaders for that asset. You can mix and match in any way you like. One of the cool things about USD, by the way, is you can have different shaders for the same asset that target different renderers. For example, you can build a character that has hair with MaterialX, and you can, for the hair specifically, you can throw in like a simple USD preview surface for the hair that targets any other renderer other than V-Ray. And if the renderer is V-Ray, you can throw in the MaterialX representation of the V-Ray hair shader. So depending on what renderer picks up the asset, if it's V-Ray, it USD,
will... So your renderer will say, there looks like there's a V-Ray shader for that, so I'm going to use the V-Ray shader or MaterialX. Okay.
Yep. And if it's another renderer, it looks up the line in the USD file that says what the material assignment is. And it looks up the non-V-Ray, like there's a generic material assignment that's not specific to V-Ray. Other renderers will pick that up, so you can have like a simple USD preview surface that any other renderer that picks up the asset will use, and you'll still get some non-empty, non-black result with it.
Okay,
and that's really cool. Right. That's really cool.
So this is all nice, and now we've talked about a little bit about what MaterialX is and how the promise of what it is. So let's talk a little bit about how people can start using it in the products that we have. So first of all, if you've got a scene you've been working on and you want to use MaterialX, you have to start from scratch, or there's a way to convert what you currently have to MaterialX?
Well, I'll be quick, including at least. Yeah, you'll probably start from scratch. I'll be honest.
You can do a conversion in Maya. If you have so when I'm saying the native Maya representation of your shaders in Maya, that means anything that's not done in the LookDefX editor, that's Maya's MaterialX editor. Mm-hmm. So if you have your native Maya representation of the V-Ray shaders, there's a utility that we added in the latest release that takes the selected shaders and converts them to MaterialX. Right now, it writes them to a MaterialX file on disk that you can only read in and apply. There's no way to stream the data into the LookDefX editor, but that's something that will likely change in the near future. But it's a way to convert and move the data. Like, for example, it should be easy to use that utility to transfer the native V-Ray shaders in Maya over to Houdini as MaterialX. But other than that, I think you start from scratch, at least for now. Start from scratch.
Is it hard to convert because of the way that it's sort of structured as an idea?
Technically, no. Okay. The hard part comes with how data is organized in Maya, for example. Right. So that's gonna take some time to explore and see what the possibilities are.
What about noises? Like a noise texture. 3D noise, 2D noise, whatever noise like is, do you use as like, okay, here's a purlin noise, and is there a definition of purlin noise inside of MaterialX, or do you sort of have to say, well, this noise, because noise patterns are going to be different, right? What's your seed? What's your this? Like all kinds of problems in that way.
There's a noise texture. I don't know what types of noise it supports. I just don't remember it by heart, but there is a noise texture.
Yeah.
With a few noise types. Gosho wanted to say something.
Yeah. Essentially, we are progressing on that one. We wanted to get the standard surface and the math nodes and the ability to sample UV coordinates and attributes on the geometry, pre-inverse, essentially, in USD terms. And we have that now. What we're doing for the procedural nodes, the procedural textures, is under the hood, so abstracted completely away. We have the equivalent of those MaterialX procedural plugins. Let's say you had the MaterialX noise. And in V-Ray itself, we're trying now to get the OSL to do the heavy lifting for us. And basically, we hope to, essentially remap, okay, that's the MaterialX node that does whatever it does. And we do the exact same thing in OSL under the hood.
In OSL. Okay, well, that makes sense. Yeah, all right. That's a good way to do it. What about compositing layers?
There's like 700 or 800 nodes in the MaterialX library. We don't.
Okay.
So really, there is a way to blend materials, but if you're asking about that Llama blended BRDF workflow, we're kind of evaluating what we can do there. So no promises there. We need to see how things progress.
Okay. Well, this is very exciting. I think, sort of implementing this is a big deal. And obviously you've been talking to a lot of our customers about what they want in terms of MaterialX. What is their biggest reason that you can think of that they've been requesting MaterialX? Is it because they want to get other data? They want to be able to convert or to work with other rendering, like assets done with other renderers? Or is it what's the motivation with MaterialX beyond? What's their motivation beyond MaterialX? Sadly
for us, being able to use the assets with other renderers is part of the requests. But it's never been a secret that even within one studio, different departments often use different renders. So it's a way to make the customer's life easier.
I see it as two ways in terms of sadly, it's not sadly at all that people want to use other
renders. It is and it
isn't. Because also that means that people can use renders that other renders and use ours as well. And I have found that whoever embraces the standard tends to win the most. And I can say that by definition because look at what happened with Houdini, who suddenly became very, very popular on the scene because they embraced USD so well. And forced, Maya is now doing great with USD because they were forced to do so, right? And I think that us sort of looking at MaterialX and it's like, yes, we support MaterialX very well. Then people are going to say, well, I can always use V-Ray because it supports V-Ray because it supports MaterialX really well. So those are things I think that are very good for us as a company to look at open standards. Like I said, Vlado's never been against open standards as long as people use them.
Yeah, like I said, it's never been a secret that even within the same studio, different departments use different renders. So and people either maintain automation that does the conversion or manually sit down and convert every node. So I see a win there. And hopefully people will see it too. But there's also customers who use different DCCs, although they use the same. They use V-Ray on both ends, and they need to be able to transfer the data. And they need the data to be to look and be editable in exactly the same way.
Yes.
And
that makes
so
sense, right? So like specifically Maya and Houdini, we have a lot of customers that use both, and to be able to make the files that can read both would be big for them in a lot of ways.
Even though there's been a way, even before we support MaterialX, there's been a way to transfer shading data between Houdini and Maya if you use V-Ray, but there's some gotchas there. Not that there's not any gotchas with MaterialX, but for example, the shading network will not look exactly the same way, because our approach in the past was to, after importing shading data into a DCC, to represent it as natively as possible to the DCC you're importing in, which is a totally different approach than compared to MaterialX, where you're agreeing on a predefined set of nodes that you use, and those nodes are present everywhere, which wasn't there before.
Right. That makes sense. Well, so tell us a little bit, and maybe Gosho, we'll start with you. Where do we stand today with our MaterialX support inside of V-Ray for Houdini and Solaris, and where do we want to go from here?
All right. Well, as I mentioned earlier, basically we got the MaterialX standard surface to be translated properly. UVs, textures, sampling of primvars, a lot of the math-related nodes. So if you want to do color corrections, that's also there. What we're trying to get going as quickly as possible is those procedural textures. They seem to be the missing piece of the puzzle at the moment. And from that point onwards, really it's it's enough for people to start evaluating whether that MaterialX pipeline is something that works for them, to give us feedback and tell us, okay, we need this or that, or maybe that's enough, maybe it's good enough. I mean, that standard surface is pretty much the equivalent of the V-Ray material, and for a lot of use cases, it's enough. But to be fair. Now, the other thing that is still missing, the other big thing is volumes. So we don't have a volumetric shader that you can apply the way that you could apply volumetric nodes from MaterialX, and that's what we're looking for to be able to do it with V-Ray 7. Some improvements there with volume rendering, but that's a different topic entirely. So let's not get into it. So procedural nodes and procedural textures and volumes is essentially what we're looking for the next few months.
Okay. Well, that's good. That's perfect. Thank you for that summary. What about you, Alex? Where are we today in Maya, and where do you hope to go?
Well, in terms of support, actually, the Houdini team is doing most of the lifting there. And it comes down to and it comes down to how we structured the way V-Ray interprets MaterialX data. We use a translation layer that actually the Houdini team built. I know that the Maya team helped there, but the idea came from the Houdini team. We use a translation layer that V-Ray itself uses that takes in the MaterialX data, and at runtime converts it to the scene building blocks that V-Ray understands. And so one benefit there is that whatever team adds support for whatever MaterialX node in that translation layer is immediately available in any V-Ray integration that uses that translation layer, which is basically it should be either all of them or most of them, which means that under the hood, even though the DCC that you're using V-Ray in doesn't support MaterialX itself, you can still use MaterialX. V-Ray supports it. But it also means that the other benefit there is that we use the same translation layer in the V-Ray Hydra delegate and the regular V-Ray. I don't know a good term for the non-Hydra delegate these days, but let's just say regular V-Ray, which means that and we use the same translation layer for USD data as well, which means that the other benefit there is that the Hydra delegate in Solaris, for example, and regular V-Ray, as in V-Ray standalone on your render farm or V-Ray in Maya, gives you the same result when you render USD or MaterialX data, which is another added benefit. But honestly, they're adding support to more nodes is thanks to the Houdini team.
Yeah. Yeah, well, this is cool. It's actually really cool to also see you two guys kind of working together, because you guys have to support it differently. I mean, not that you didn't work together, but there's actually a lot of motivation for you guys. Like here's everything I've done for MaterialX, and then you're able to integrate it together, because that's kind of the point of these standards, is that you can share data too, right?
And it also creates interesting situations for us where we sit down and look at how things are done in Maya compared to Houdini. Realize that sometimes something is way easier in Houdini, or at other times something is way easier in Maya.
Yeah, that's cool. That's cool. Well, listen, guys, this has been great. I'm glad we're able to talk about MaterialX and all these things that are going on. It's very exciting to see where this is going. I know people have been wanting to hear more about this and very excited about where it's going. So I'm sure if people want to have more questions about MaterialX or would like to have more features added, and you guys heard it here first. I mean, these guys tend to listen to what people want and add it as features in the next version. So your feedback is important in this stuff as well. But thanks, guys. What are you guys looking forward to the most?
Volumetric rendering.
Vacation.
A vacation, nice. Well, I like one's volumetric rendering is like vacation. Yeah. No, but yeah, it's true. Volumetric rendering is actually a big one that we're actually doing a lot of work on, and it's coming up in the newer versions of V-Ray as well. So big changes happening there with volumetric stuff, which is very exciting.
Yeah, research and work there is already ongoing, so it's gonna be really interesting to see the results.
Yeah, for sure. And I know people are asking a lot of stuff that's happening in the lab as well. We'll cover some of that on the podcast in terms of all the next stuff that we're working on as well. So we'll be covering that at some point. But cool, man. Thank you guys so much for talking to us about MaterialX. Hopefully, I know it's late at night in Sofia, and I appreciate you guys getting on at this hour to cover this. It's good seeing you guys again, too.
Thanks for having me.
Talking to you.
Bye, guys.
Bye-bye.